Welcome to this session on Anyscale on Azure. I'm Katarina, a product marketing manager at Anyscale, and I'm joined today by my colleague Daniel Arrizza, a field engineer here. Quick agenda. I'll cover why teams are choosing to own their AI stack, what makes that hard to scale, and how Anyscale on Azure addresses it. Daniel's going to follow with a technical demo, and we'll close with some next steps. To jump right in, every team building with AI today is making a choice on a spectrum. On one end, you can rent intelligence, calling someone else's model through an API. On the other end, you can own it, and owning is not binary. It's a spectrum that includes deploying open source models, customizing open source models with your own data, and training your own models. Most teams use a mix of both renting and owning. The question is when ownership makes sense for a given workload. So when is that the case? It usually comes down to a few things. Control over your models and your operations, so you're not exposed to model deprecations, rate limits, or outages. Data and differentiation, when you need to keep proprietary data inside your boundary. And cost and latency, for better unit economics at scale and faster end-to-end response times. When one or more of these apply, that's typically when we see teams move towards ownership. But here is the challenge point. Building AI is getting harder because both data and models are scaling fast. What used to be structured tabular data is now multimodal. Dataset sizes have moved from gigabytes to petabytes. Single models are now many models, and parameter counts are growing exponentially. Across the AI lifecycle, that complexity is showing up everywhere. Building requires coordinated CPU and GPU compute. Training must be distributed across nodes with fault tolerance built in. And serving requires composing many models, often on different hardware. These are problems legacy tools were not designed for, and teams are increasingly hitting their limits. It's why we're seeing teams converge on Ray, the open source distributed compute framework for Python and AI workloads. As AI workloads have grown in scale and complexity, so has Ray adoption. It has over 12 million downloads per week, and it's the most widely adopted AI compute framework across both AI labs and enterprises, used by teams like OpenAI, Uber, TripAdvisor, and more. So this brings us to Anyscale on Azure, from the creators of Ray and powered by Ray on AKS. 3 core things to know. First, it accelerates dev to prod with a unified runtime for multimodal data curation, distributed training, and multimodal online serving. Second, it runs reliably at scale with a fully managed Ray lifecycle on AKS, a priority-aware scheduler that maximizes GPU utilization and 24/7 Ray expert support. And third, it's Azure native, it runs on AKS in your own subscription, integrates with Entra ID for RBAC, and is available through the Azure portal. So your data and IP stay inside your existing security and governance boundaries. So with that, I'm going to hand it over to Daniel to walk you through what building, training, and serving on Anyscale on Azure looks like in practice.
All right. Well, thank you, Katarina, for that intro. Now that we have some more context as to the types of problems that we solve, I'm going to get into the technical demo. And this is going to start with a very brief part of looking at the infrastructure and how we set up a console of any scale in the Azure console. And then from there, we will look at a actual use case of creating our own recommendation engine and how we can do fine tuning, batch embedding, serving, things like that. All right. So I'm going to start here in the Azure console, and I want to create an Anyscale cloud. So to do that, I just say from Anyscale clouds, I'll say create, and it'll ask me for a few details like what subscription I want to launch this in, what resource group, and I'll just pick one that I've created earlier, the name of my cloud, so my cloud, and what region I want to launch things in. And then I can select an AKS cluster. So if you've used Kubernetes before, already have a Kubernetes cluster set up, we could deploy straight into that. If you're not a Kubernetes whiz, then we have a one-liner to just create the Kubernetes cluster for you, and you don't have to think about the infrastructure side of things if you want. But the good thing is we integrate very, very deeply inside of Kubernetes. So we have all the power of that really rock solid infrastructure layer. So I'm going to pick a cluster that I had earlier, and I'll say next. I'll pick a couple things here, just so the storage account that I'm going to store things in, and the identity I'm going to use to connect to that storage account. And then I'll pick an Azure container registry. It's just going to create all these new resources for me, and support plan, tags, and we're off to the races to be able to get this thing started. All right. So I can hit create, and then it'll go off and create this for me. This takes a little bit of time, so I've already pre-created this for you. And let's launch up the Anyscale cloud. So here is the cloud that I pre-created. And now I'm going to show you what the console looks like, its capabilities, and then we'll get into the notebook. So the main three things on the left here are workspaces, jobs, and services. Workspaces are for interactive development, as you want to be able to write some code, run it, see how it works, look at observability, like your metrics and logs and things like that. Workspaces will be for that interactive stuff. Once I have some code that I want to run on maybe a larger data set or a more production environment, then I'll launch a job, and a job will run. It'll work over time in the background. When it's done, it'll turn off the cluster. And lastly is a service. So a service is an always on, ready to listen to requests to be able to serve up your models. And yeah, so that's our services over here. So I'm going to start in workspaces. We'll spend the majority of our time here. And I'm going to open up a workspace. Just note that if you want, there are many templates available as well too. So you can pick up a bunch of templates that we have on if you want to do some inference or some training or be able to create a RAG system. All that's here. So I'm going to open up a workspace. And in my workspace, I am starting here with a workspace that I've already pre-created before. On the right, you'll notice that I am running on a Ray cluster here. So this Ray cluster has 8 CPUs and 32 gigs on one node. And I have only one worker node for now. This is just one CPU-based node. But if I wanted to add a whole bunch more nodes, I could really, really easily scale this up by hitting add worker nodes. And say, maybe I want some GPUs, I want some A100s, and I want 10 or 100 or maybe 1,000, depending on how much availability and scale that you need in your environment and for the job you're running. But there isn't a lot to do in order to be able to scale things up, and it makes that really, really easy to do. For now, I'm just going to run this on a CPU-based cluster just because I'm just testing out some things for now. So I want to launch into the code part of it, and I could launch a VS Code desktop connection to this cluster. And so I can go up here and say open in VS Code desktop, and it would launch up VS Code desktop and SSH directly into this cluster. And that's really great because that means my development and my production environments are very, very similar. I'm running on the same type of hardware, same type of environment. But instead, I'm going to open up VS Code, and I'm going to have a little web interface to be able to do everything that I want here. I have all my code in here in this notebook, but I can have many Python files, of course, too. I can install many dependencies as well by installing through pip, or if I go to dependencies, I can add them over here as well, too. I can also freeze all the dependencies and everything into a container image, so I have a fully reproducible environment. So going from that development to production, once again, a lot easier to do. So I'm going to be in the code here, and I'm going to walk you through a use case. And the use case is I want to create an e-commerce recommendation engine. And I had a few choices, like Katarina mentioned. I could go and use an endpoint from one of the AI model providers, but that probably would be very expensive to run, and I lose control over everything. But then the next step is to use an open source model, and that's a lot cheaper to run, which is great, but it's probably not as effective because it doesn't really know my data, and there's smaller models in general. So what I want to do instead is I want to fine tune an open source model, and I'm going to use Ray to be able to do that. And to do the fine tuning, all that training, I'm going to need some data processing as part of that. And lastly, once I have my fine-tuned model, I'm going to want to be able to do some batch embeddings. So I want to do some inference on that model with all the data that I have. Right. So that's kind of the use case that I'm setting up here. And think as well that I probably have, for a large e-commerce store, I have maybe 1 million products. 10% of them are changing week over week. And so I need to constantly be rerunning this thing. And so that's going to need to be a job that I'm going to schedule after as well, too. And we're going to need some scale to be able to deal with that level of data and to make this like a really good model, right? The other thing about this use case is that it's multimodal data, right? So I have not only text descriptions about the products, but I also have images that show what the product looks like, right? And so when I'm creating an embedding space to show how similar things are to each other for recommendations, I'm going to need to be able to process all of that multimodal data as well together too, right? And lastly, when I serve it, I'm going to need multiple models. Maybe I'll need one model for doing some image to text. I'll use my fine-tuned model after as well too, and I'm going to need an endpoint to be able to serve all that. So I'm really trying to show you a really full end-to-end solution here, where I'm doing pre-processing of data, I'm doing some fine-tuning, doing some batch embeddings, and then I'm serving all of that. And that's what this use case is really for. Okay. So let's get into the use case. Starting here with installing all my dependencies and looking at all the images that I have for just a sample of images that I have on of my product catalog. And so the first part here is just sampling some of the data and creating a training data set. And so I've sampled some of the records to create my training data set. And down here, I'm in this Torch trainer. I'm going to make this a little bit bigger, a little bit easier to see. Okay, so in this Torch trainer, so I'm actually using PyTorch, right, which is an open source, very, very commonly used library for doing deep learning and AI. And what is special about Ray is that it doesn't take that stuff away. All it does is it wraps a lot of the open source regular frameworks that you use and creates an orchestration layer around all of it so that we have better performance and better stability and also great scalability. So being able to increase to many, many CPUs, GPUs, all that kind of stuff, all right? So my Torch trainer, I'll go into this in a second, but this is my PyTorch code is basically in here. I can say what kind of config I want to run, how many epochs, my batch size, things like that. How much I want to scale. So maybe I want to run on one worker, maybe 1,000 workers. How many GPUs do I want to scale on? And some things like checkpointing here as well too. So one great thing about Ray Train is that what it can do is if there is a failure at any point, it can really easily resume from where it left off, even mid-epoch. So you're not having as many failed runs and you're able to resume your runs as well too. So it is really able to work with this scale where things are not always running as seamlessly as we want, as we do just like one machine on my laptop. This is being able to scale to thousands of GPUs and still run in a reliable way. So just opening up that train loop per worker code, I just want to open that one up. And I have it right here. So the code itself, I have a little bit of data loading. So I'll talk about Ray data in a second. But right here is some standard PyTorch code, right? So, but if I want to add checkpointing, all I need to do is add a little bit of checkpointing code right here. It's just basically 10% more code than you would normally have. But then it does all that reliability and checkpointing for you, all right? So the other part here is this data loader, right? So I'm actually using Ray data to be able to feed in data to this Ray train portion, right? And what Ray data is helping me with is allowing the data to stream to the GPU, keeping the GPU always fed, as in it always has data to work on. So you're fully utilizing your GPU. You're not getting those 20, 30% GPU utilization, which is such a shame because we have such little availability of GPUs. And if you're not keeping them fed, you're wasting money or just wasting the potential of how good your model can get. So Ray data is streaming the data always to the GPU, keeping it ready to go. And so that's pretty awesome that it's able to do that. And the other reason why it's able to do it is because it can scale up some CPU nodes so that the CPU is not the bottleneck. I can create as many CPU nodes as I need to be able to keep the GPUs always fed. All right. So that's pretty cool. And I ran that earlier and just only on a couple epochs here. And so I can see that my training loss went down. So that's good to see. Next, I'm going to do some batch embedding. So actually, I already have a fine-tuned model now, so that's great. I'm going to load in that model and then do some batch embeddings. So I have my embedding code in here. How big I want to run this on. This is running on only one CPU, but I can scale this to num GPUs 1,000 if I want. So very, very little code needs to change there. And it embedded the products, right? So let's see if that embedding model is good. So right here, I'm going to look at the product embedding similarity. So I can see that speakers and laptops and webcams are all pretty similar to each other, but not very similar to shoes or sweaters, right? So, just very basically, you can do that type of embedding and see what's similar to each other. And I can see previously with the open source model, my light blue here is not all together necessarily. But if I look here, things are just a little bit better clustered together than they were in the base open source model. So my fine-tuned model is just looking a little bit better than the previous one. Yeah. And I can also see here comparing the base model to the fine-tuned model and how things have gotten better. So that's great. So I've done my batch embeddings, my fine-tuned model, and it's looking like better results than the open source one. So lastly, I want to show you in this code here the serving model. So I want to create an endpoint where it is listening in for recommendation requests and running through a couple models, starting with an image to text model, and then going to running my actual fine-tuned model. And what I would do without Ray here is maybe create a whole bunch of microservices and try to get them all deployed in Kubernetes. That could be kind of a pain to do, to stitch all that stuff together. But instead, the code is a lot simpler when I use Ray serve. So I'm going to open up the serving code. But you can see right here, actually, I've run the service and run some recommendations, and I can see what is similar to travel wireless headphones and other wireless headphones, of course, pretty similar to it, and what other recommendations would be similar. And then I'm going to open up this serving stuff here and see that it starts with a recommendation endpoint that takes in an image, runs through my image to text model, and then the fine-tuned model, the one that we created earlier, and returns a JSON response. And I'm going to show you, in here, we can just call it right here if we want. But then if I want to deploy this on Anyscale so that it's always available, this Anyscale service deploy will get this thing up and ready to go. And as I have new versions, it'll be able to have zero downtime as I be able to create new versions and scale this thing up as maybe I'm getting more requests to one model versus another, and they can scale things independently. It has prefix-aware caching. So really, really, really cool stuff built in here. So yeah, all the serve code is in here. So I can see my image to text model, and I load that one up and create some captioning. And then I can run my product recommender one as well too. So this is the fine-tuned model, and I'm loading up my model and running this embeddings norm. So this is just a little bit of PyTorch code. So pretty standard stuff here. All right. Okay, so that's my serving side. So you've seen a little bit of the code, right? Just note that you don't necessarily need to write all this code by hand. We actually have some agents that make working with this a lot easier. So I'm just going to load up my terminal, and I can see if I have Anyscale. I have my Anyscale CLI installed, and I can say Anyscale skills, and we have a whole bunch of skills available to run in your favorite code AI assistants, like being able to set up the infra, setting up the platform, and then actually creating workloads like Ray data, serve, train, serving, and more coming. We have RL for post training, a lot available there. Right. The CLI also you can use create jobs and services. But anyways, yeah, the setting up all the skills, it's all available here. And those skills can also know how to go to the metrics and observability that's available in the workspace. So in the metrics tab, I can see a lot of information about what is going on around utilization, how many nodes, my memory, CPU, a lot of information. That's just core stuff, and getting into all the libraries that are in Ray. And if I open up Ray workloads, it'll also, I ran this earlier, I can get really deep into the different stages and figure out where my bottlenecks are. And if I'm not an expert in this, then my agent can know to be able to grab all this stuff and do some writing of the code and also optimization of the code as well too. So really, really powerful. And that observability is something that is really key for not only like the day one if I wrote a little bit of code and it kind of works, but also the day two when I've scaled things and things aren't working as well as they were before, and I need to do some debugging and things like that as well too. All right. So there's a lot more in the platform. I just wanted to show a little bit of the Workspaces job services, getting to the code, into my cluster config, talking about some of the Ray libraries, and then some of the observability and agents. So hopefully that gives you kind of a quick orientation as to like overall what's all in here. So I'll hand it back to Katarina to talk about next steps. But thank you for checking out this part.
Thanks for joining us today. If you'd like to learn more, the first QR code takes you to our webpage for the Build conference, where you can see our scheduled table talks, including one that Daniel is leading on building multimodal data pipelines, and you can also request a meeting with our team. The second QR code gets you started on Anyscale and Azure, so you can try everything we just walked through hands-on. And if you're at Build in person, come find us at booth G201. We'd love to meet you. Thanks again.